Now let's start this paper by looking at question 1, where we are told that a block B of mass 2.7 kilograms is pulled at constant speed along a straight line on a rough horizontal floor. The pulling force has a magnitude of 25 newtons and acts at an angle of theta above the horizontal. The normal component of the contact force acting on B has a magnitude of 20 newtons. Show that sine theta is 0.28 for 2 marks. You find that in this question there is plenty of information. I usually recommend that when you are confronted with this kind of question, the first thing is to put this information on a simple sketch. For instance, I would just draw this block over here and show the forces which are acting, because we cannot do mechanics without involving forces. So we are told that there is this 25 Newton force. It is acting at an angle theta to the horizontal. This angle here is theta. It's got a mass of 2.7 kilograms, so its weight must be mg. M is 10, so its weight becomes 27 newtons. And we are told that the normal component of the contact force R, which is the amount of force which is exerted at 90 degrees to this object by this surface R, has a value of 20 newtons. Now you find that the first thing we must do is to resolve this force. So let me do exactly that. So the horizontal component of the 25 Newton force in this direction will be 25 cos theta, and of course the vertical component will be 25 sine theta. And then we are told that this one is a horizontal floor, so there must be friction force in this direction here, which we are going to represent it by that value. Of course, since it is moving, it is equals to mu r, if we ever need that information. So we are asked to show that sine theta is equals to 0.28. Now, this object is in a state of equilibrium, both vertically and horizontally. How do I know that it is in a state of equilibrium horizontally? I've been told that it has constant speed. It's moving in a straight line and it has constant speed. That means that the acceleration in this direction is 0. Since it is 0, it tells me that the resultant force horizontally is 0. And it follows without saying that its resultant force vertically is also 0, because it is not moving in the vertical direction. So since the vertical component, since the resultant force vertically is 0, then it tells me that the sum of the upward forces, which is 20 plus 25 sine theta, is equals to the sum of the downward forces, which is 27. And the moment I have this, I know I can subtract 20 from both sides. I get 7, and then I divide both sides by 25, and I'm going to get sine theta to be 7 over 25. And if you use your calculator, you're going to find that this one is 0.28. So the most important expression here is this point here. You must be able to come up with this expression. Let's look at part 2, can just be able to write part 2 over here. Now, what are we asked in part 2? In part 2, we are asked to find the work done by the pulling force in moving the block a distance of 5 meters. Work done. The work done is going to be equal to the horizontal component 25 cos theta times the distance, which is 5 meters. 5 meters. And since we know cos sine theta to be 0.28, I can work out that theta. So shift cos inverse of 0.28, and that angle is 73.7. So since theta is 73.7 degrees, this one will be 25 cos 73.7 times 5. Or I can do sine of the answer when it has all those number of significant figures, and then I multiply that by 25 and by 5, and I'm going to get 120 joules, an exact value, 120 joules. And that is how we would work out question number 1. Let's go to question number 2. In question 2, we are given this information: 3 horizontal forces of magnitude F, 63 and 25 newtons, act at O. The origin of the x-axis and the y-axis. The forces are in equilibrium, so we know that the resultant force on the system is 0. The force of magnitude F acts at an angle theta anticlockwise with the positive x-axis as shown. The force of magnitude 63 acts along the negative y-axis as shown. The force of magnitude 25 newtons acts at tan inverse of 0.75 anticlockwise from the negative x-axis. Find the value of F and the value of tan theta. So, the moment we are given a question like this, the best thing is to realize that we just need to start resolving each of the forces in 2 standard directions. I'm going to find its component in this direction, the component of F in this direction, in which case that one will be F cos theta. I also resolve it vertically upwards here. Of course, the line is already there, so I should just have written F sine theta. Then I get this 25 Newton force. I resolve it vertically upwards. If this angle is, let me see. First of all, I'm going to resolve it this way, because I'm going to say that this angle here, which I'm going to call, let me just call it alpha. Alpha. If I get cos of alpha, I'm going to have this one to be 25 cos alpha, while this one will be 25 sine alpha. So if I can be able to get alpha, I can be able to solve that question very easily. So I've already been told that alpha is equals to tan inverse of 0.75. 0.75 is like 75 of 100. This is like tan 3 over 4. Tan inverse of 3 over 4. What this means is that tan of alpha is 3 over 4. It's better to write it that way. So alpha, that means that let me draw this right angled triangle here. If this is alpha, and we know that tan of an angle is opposite of adjacent, this will be the opposite, this will be the adjacent, and then the hypotenuse is going to be 5, definitely. So if I need sine of alpha, I can get it. If I need cos of alpha, I can get it, because sine of alpha is opposite of hypotenuse, 3 over 5. Cos of alpha is adjacent over the hypotenuse, which is 4 over 3. This is what I mean, although it should be quite direct from this, that the cosine of alpha is 4 over 5 because it is adjacent over the hypotenuse. Where am I going to get this? Where am I getting these values from? I'm getting these values from this acronym here, SOHCAHTOA, which states that cos of an angle is, the cosine of an angle is adjacent over the hypotenuse, adjacent over the hypotenuse. The sine of alpha is opposite over hypotenuse. The opposite to the angle is 3. The hypotenuse is 5. So if I need cos alpha, I substitute it with 4 over 5. If I need sine alpha, I substitute it with 3 over 5. And you can see those values are required here. So let's go on. 63 will not be resolved because it is in the proper standard direction. It is vertically downwards. Remember here, the best directions will be horizontally and vertically. So the system is in equilibrium, so I'm going to get the sum of the upward forces. Sum of the upward forces, which is F sine theta plus 25 sine alpha. Sine alpha is 3 over 5, so I can just multiply it by 3 over 5 direct. So I have this plus this should be equal to 63. 63. And we see that F sine theta, since this 5 gives me 5 here, I get 15. I'm going to do 63. I subtract 15. 63 minus 15. And I get that one to be 48. And I can't go any further as far as that expression is concerned. So I can call it equation 1. Let me see whether I can get F cos theta. So let me go on. I'm going to equate forces to the right, which says that F cos theta, F cos theta is equals to forces to the left, which is 25 cos alpha. 25 cos alpha, we have just seen that cos alpha is 4 over 5. 4 over 5. And this, since this one is 5, I'm going to get this one to be 20. And that one will give me this expression. F cos theta is equals to 20. Again, I can't go further than this because I've got two unknowns, theta and F. This becomes my second equation. Now, when we look at the question, we are asked to find the value of f. See that? And then we are asked to find the value of tan theta. Not theta, but tan theta. So, from here, since I know in equation 1 I've got sine theta over cos theta, you should be able to remember that if we divide sine theta by cos theta, you should be able to get tan theta. Should be able to get that. So that tells me that if I divide this equation by this equation, I can get tan theta, because f and f will cancel out, and therefore I'm going to have tan theta is going to be equal to 48 over 20. 48 over 20. I can cancel out by 2, I get 24. Cancel out by 2, I get 10. And I'm going to find that tan theta will be 2.4. Already I have the first answer. Tan theta is 2.4. Now I can use that tan theta, or I can use the theta itself to get f, because I'm going to go right ahead, and from here I can be able to get my theta, which will be tan inverse of 2.4 Let me see, it doesn't contradict this one. I think there is no problem there. There is no mistake here. So I can get the theta itself. I do shift tan inverse 2.4, and that should be able to give me 67.4. Theta is 67.4. Having obtained that, I can get one of the equations now and say that over here you can be able to say f is going to be equal to 48 over sine theta. F will be equal to 48 over sine theta, which is sine of 67.4. So let me see which will be the best method. I'm going, because I have the 67.38013505, very many number of significant figures, I can just do 48 divide by sine of the answer, and that should give me 52. So F is 52 newtons. And that is how I would get the answer to that question. Notice the starting point. The starting point is where I'm told that the forces are in equilibrium. And the moment I'm told that, I know that if I resolve the forces in such a way that all the components are perpendicular to each other, then I can resolve in one direction and get 0, resolve in the other direction which is perpendicular to the previous direction and also get 0. Or alternatively, in a very simple way, I can just get the sum of forces in one direction. They should be equal to the sum of the forces in the exact opposite direction. In this case, sum of forces to the right should be equal to sum of forces to the left. Similarly, sum of forces upwards should be equal to sum of the forces downwards. And that is how we would solve question number 2. Let's go to question number 3. Now, before you go to question 3, I'd like to point out that when you look at this one can be simplified further, in the sense that we can get this being 24 over 10 can be simplified into 12 over 5 because of this. So the answer can as well as be tan theta is equals to 12 over 5, because if we draw this right angled triangle, and I'd like you to understand why we are doing this. In most of the time in mechanics, it's always, if you observe carefully, the use of the calculator is discouraged a lot because values have been chosen in such a way that they cancel out so well. Tan of theta will be opposite over the adjacent. The hypotenuse here, this will be 12 squared, which is 144, plus 25, which will give me 169. If you do the square root of 169, you get this one to be 13. You get it to be 13. So that even in the answer, in our calculating the value of f here, you can say that f, so where am I going to write this? Let me just erase this and write my work here. It's quite crowded, but I hope you're following. I'm going to use this expression to get the value of f. So I'm going to get f times sine of theta. Sine of theta will be opposite over the hypotenuse, which is 12 over 13. And that one is given, was giving us 48. So the value of f will be equal to 48 times 13 over 12. And you can see that this goes here, and when it goes here 4 times, and you can see that will be 52 newtons. So you can see it cancels out so well, and this is what I was talking about. Now, what are some of the hints that you are supposed to use this kind of method? You'll use this kind of method when you find that the trigonometrical functions of various angles are given as ratios 3 over 4, and if you try to draw a right angled triangle using those values, you find that their sides work out so well. When you find out that that is the case, that is probably the best method to use. But that does not mean that the first method, where I worked out the angle or theta to be this much, that it's wrong. No, it's not wrong, because there is nothing in the question that tells you that you must be able to follow this. It's only that the only thing that you've got to ensure is that you follow the instructions that have been given in the question. With that, let's proceed to question 3. And here we are at question 3. We are given that a block of weight 6.1 Newton slides down a slope inclined at tan inverse 11 over 60. That angle theta, this will be the slope. If we call this to be theta, then the tan of theta is going to be equal to 11 over 60. I don't know whether this one will give us what I've just talked about here. This will be 11 because it's the opposite. 60 will be here. Let me see whether I can be able to get the hypotenuse. That will be 60 squared plus 11 squared, which is that, and then I get the square root of that answer. Should get 61, and indeed it gives me the hypotenuse to be 61. So if this is theta, that is theta there. If I want cos theta, it's 60 over 61. If I want sine theta, it's 11 over 61. And of course, if I want tan theta, it's given. So that one works so well, and I'm 100% sure that this is the method that the examiner wants us to use. The coefficient of friction between the block and the slope is 1/4. So I'm going to get this block here. It's got a weight of 6.1 newtons. That means that its mass is 0.61 kilograms. We can resolve its weight down the slope, which will give us W sine theta, which will be 6.1. Sine theta is opposite, which is 11/61. Notice what I'm talking about. You see this 6.1 here divided by 61. If I divide, I get 10 here, and dividing 11 by 10, I should be able to get 1.1 newtons. So I already have the component of its weight down the slope being 1.1 newtons. Let me just confirm that 6.1 divided by 61 is 0.1. I multiply that by 11 and I get 1.1. The component of its weight perpendicular to the slope here will be W cos theta, and of course that one will be W 6.1 cos of theta. Cos of theta is 60/61. Again, that will be 6.1 divided by 60. I don't know why 61. I get 0.1. I get 60 times the answer, and I get 6 newtons. So it's going to be 6 newtons, like that. So let's go on. It slides down the slope. Since it is sliding down the slope like that, and remember there is R here, there should be friction force acting right in the opposite direction like this, and friction force is going to be equal to mu R, and R is equal to 6. R is equals to this value here, which is 6, and here I'm going to get 3/2, which is 1.5 newtons. You can see how values are working out here. The block passes through a point A with a speed of 2 meters per second. So at a certain point, at a certain instant of time, when its speed is this much, find how far the block moves from A before it comes to rest. So let me read this question once again, because I want to ensure that the acceleration is constant. A block of weight 6.1 slides down a slope inclined at that much to the horizontal. The coefficient of friction between the block and the slope is that much, and the block passes through a point A with that amount of speed. You know what that means? If we've been given the speed at a particular instant of time, it means at that instant of time we can be able to use F is equals to ma in order to work out the acceleration. Why would I need the acceleration? I would need the acceleration because it will help me to get the S. Since I know the U, let me ensure that the acceleration is negative first of all. The resultant force will be 1.1 because it is accelerating down the slope. Let me use double arrow there to show that. So the force acting down the slope is 1.1 minus 1.5 is equals to 0.61 times a. This is negative 0.4 is going to be equal to 0.61 a, and our a is 0.4 divided by 0.61. That will be the acceleration. Maybe it's going to give me a, don't know whether it will give me an exact value, divided by 0.61. No, it doesn't give me an exact value, but not to worry. This one gives me 0.6557. I can say it is 0.65, let me just say 6 meters per second squared, and of course it's negative. It's negative. Don't forget that there's that negative there. So I'm certain the block is slowing down, and at some point it will come to rest. I do not know its initial velocity. I'm just so told that it was just sliding down the incline. So the block passes through a given point A with a speed of that much. So find how far the block moves from A. So indeed, I now am sure that I know the value of u. Whatever I used as a v here in order to help me work out the acceleration becomes my u. 2. Our v is 0. A is known, is minus 0.656, and it's s that I want. So I can use the equation v squared is equals to u squared plus 2as, and I can get the s by doing v squared, which is 0 squared, minus the u squared, which is 2 squared, which is basically it's 4, divided by 2 times a, and a is 0.656. So it's going to be minus 4 over minus, let me see that, 0.656 times 2 will give me 1.312, 1.312, and this one will give me positive value. I mean, given that that will be 4 divided by the answer that I've just got, and I should be able to get 3.048. I can say it is about 3.05 meters. This how far it slides down the incline. I want to emphasize this point, that when you are working out these questions, it is important you look at, you use certain skills. What are these skills? I've already pointed out one of them in this paper. When an angle is given as a trigonometrical function and it's given as a ratio of two numbers, always try to find out whether the right-angled triangle can give you all the sides exactly, so that you can get the sine and the cosine without any problem. The other one is this: consider all the information that is given in order to be able to work out what you need. You need to ask yourself, why is the coefficient of friction given? That means Fr is equals to mu r is required. Why have I been given the speed at a point? There were two reasons why this one was given: to enable you to use the third equation of uniformly accelerated motion, and to enable you to calculate acceleration at that particular point. Now, how did I come to know that the acceleration is uniform throughout? Is because these forces are not changing. This component is not changing, this component is not changing, so the acceleration must be uniform. So by working out the acceleration at a given point, it's as if I've worked out the acceleration throughout the whole motion. And that is how you would work out question number 3. Let's go to question 4. And always remember to confirm the answers, because I know you have an access to the marking scheme. Just confirm the answers that we are working out here, whether they are in tandem, whether they are agreeing. If they are not agreeing, then let me know in the comments below where maybe I've made a mistake, and then we can discuss that one further. So let's go to question 4. Now question number 4 is quite lengthy, but not to worry. Let's go through it together and see what we can make of it. We understand the question, and then we see what concepts we are supposed to use. And let's read it together. A lorry of mass 14,000 kg moves along a road starting from rest. So that tells us the initial velocity is 0. At a point O, it reaches point A and then continues to point B, which it reaches with a speed of 24 meters per second. So we know the speed at point B is 24 meters per second. There is point A. We haven't been given much information about point A. The part OA of the road is straight and horizontal and has length 400 meters. The part AB of the road is straight and is inclined downwards at an angle theta to the horizontal and has length 300 meters. So at least now we've got the situation. This is a situation. The lorry moves horizontally like this from O to point A, O to point A, then from A to point along AB. It is inclined to the horizontal at some angle theta. So this distance OA, we've been told, is 300 meters. 300 meters. It's right here. The part AB of the road is straight. AB of the road is straight and inclined towards an angle theta to the horizontal and has a length of 300. I think it is AB. AB. Let's say B is here. It is the one which is 300 meters. OA, on the other hand, I think it's 400 meters. The part OA of the road is straight and horizontal and has a length of 400 meters. So this is the one which is 400 meters. And of course, our lorry is here. It's got a mass of 14 tons. What other information is given? For the motion from O to B, O to B, find the gain in kinetic energy of the lorry. So the U here was 0. V here was 24 meters per second. So we can definitely calculate the gain in kinetic energy of the lorry and express its loss in potential energy in terms of theta. So the loss in potential energy will be due to this change in height here, this h here, and notice that this is a right-angled triangle with the hypotenuse given, and we know the opposite. That means we need the sine of theta. We need the sine of theta. So any other information? Let me first of all work out the gain in kinetic energy. I'm going to work it out here. The gain in kinetic energy is going to be equal to a half times the mass, which is 14,000, times the v squared, which is 24 squared, minus u squared, which is that much, and that will be like 24 squared times a half of 14,000 is 7,000 times 7,000. So 24 squared times 7,000. I think there is no other number that I've missed out, and that will be 4,032,000 joules. That will be the gain in the gain in kinetic energy, 4,032,000 joules. So no problem with that. Express the loss in gravitational potential in terms of theta. I'm going to work out the gain in potential energy. I'm going to call this one to be the gain in potential energy because there is an expression which I know must be used, and this is work done on the lorry by external forces is equal to gain in energy of the lorry. The two external forces are usually frictional force and driving force. So we need to find out the work done by these two external forces. And then we need to find out the gain in kinetic and the gain in potential. That is why I'm calling this the gain in potential energy. But I'm going to follow the instructions here and work out the loss in gravitational potential energy, which definitely will be equal to mgh. What is my m? 14,000. What is the g? T. What is the h? I should know that sine of theta is equals to opposite over hypotenuse, 300. This implies that h is equals to 300 sine theta. So it's not possible to work it out as an exact value, and in fact even in the question they don't expect us to do that because they've asked us to calculate the loss in potential energy in terms of theta. So this one will be 300 sine theta. Let me just get rid of that in order to create some space there. I'm going to write down that answer. So I have 14,000 times 10 times 300, and I have quite a large number, 42 million. 42 million sine theta joules. That is the gain in potential energy. I mean the loss in potential energy as the question talks about. So I think this one we're still in part 1. We haven't gone to part 2. So that is how I would get those answers. The next information is this: the resistance to the motion of the lorry is this much, 4,800 newtons, and the work done by the driving force, notice, work done by the driving force on the lorry from O to B is 5,000 kilojoules. So I have got to work out, find the angle theta. Okay, fine. In order to simplify this, the work done by resistance force should be equal to minus, I'm going to give it a negative sign, times the total distance moved. The reason why I want to give it a negative sign is because I'm talking about work done by resistance force. The work done by resistance force will be, of course, be 4,800 times 400 plus 300 will be 700, and this will be minus, that will be 4,800 times 700, and I have 3,360,000. 3,360,000 joules. I already know that the work done by driving force is 5 million. Now, what expression do I need to use here? The expression is very simple. Work done by external forces is equals to gain in energy. Gain in energy. But probably it would be good to state this in words, because these are just symbols that I'm using that I like to use, because these past papers, the concepts are almost like the same. So when I've got to repeat a particular concept, they are symbols that I normally use. So when I use delta WF, it means work done on the object by external forces. When I use delta E, it means gain in energy of that object. So let's substitute work done by driving force plus work done by friction or by resistance is equals to gain in potential energy plus gain in kinetic energy. I have to treat these energies as gains of energy. It is gaining energy. So wherever it experiences a loss, I put a negative sign. And this is what we mean. Work done by driving force, there is no problem with that, because that will be 5 million. Work done by resistance, there must be a negative sign to that, because the resistance force is always acting in the opposite direction to the direction in which the object is moving. So if I resolve the resistance force in the direction of motion of the object, I must do FR cos 180 degrees. Cos 180 degrees is -1, and that is where -1 comes in, because I'm talking about work done by. Work done by. Get used to that. Get used to calling this quantity here work done by resistance force. Gain in potential energy, I'm going to put a negative sign here because I'm calling it a gain, although I know it's actually a loss. But according to the principle, I want it to remain a gain. There is something I've forgotten here. This is sine theta plus this. Quite a huge number here, but not to worry, so long as my most important aim My aim is that you understand what we are doing here. So that is it. So let me work out these values here. So I have 5 million, quite large numbers, minus 3,360,000, 3,360,000 minus that. Then the other one crosses the equal sign. It becomes minus 4,032,000, 4,032,000. So it was positive, it becomes negative. I have equal to, this will be negative 2, 3, 9, 2, 1,000 is equals to negative 42 million sine theta, and sine theta, or let me just say that this one will be equal to 2,392,000 divided by, of course the negative signs are going to cancel out. I've got 42 million. 1, 2, 3, 1, 2, 3, 1, 2, 3, and this one will give me 2,392 divided by 42,000, and I get 0.05, 0.05695 recurring, and I can get the theta by doing shift sine inverse of the answer, and I should get 3.26, which is about 3.3 degrees. 3.3 degrees. And that should be the answer. Now, how do you get started with the questions involving energy? Remember, there are two types of energies that you want to be looking for in Mechanics 1. Number 1, gain in kinetic energy. And a gain is always a half m into v squared minus u squared. V squared, v is the final velocity, u is the initial velocity. Don't interchange those values. Even if u happens to be larger than v, always maintain v squared minus u squared. Then gain in gravitational potential energy. Be on the lookout here. If there is a decrease in height, your gain in gravitational potential energy will have a negative sign. But if it is increasing, then it's all right. Your gain in gravitational potential energy is in order. The driving force. Work done by the driving force. There's no problem with that. But work done by resistance, you must always give it a negative sign, because it is always making an angle of 180 degrees with the direction of movement of the object. So this question appears to have a lot of information that you need to put into account, but I've shown you how to break it down step by step. And in fact, the examiner helps you. You see the way the examiner works. First of all, the examiner has you working out the gain in kinetic energy. Then the examiner has you working out the gain in potential energy, gravitational potential energy. Then works out work done by resistance. But the examiner always introduces or uses these terms here. Wherever there is a negative sign, the examiner will call it a loss, which is all right. So go with what the examiner wants to write down. For example, over here, I never wrote down a negative sign because the examiner wants me to write the loss in gravitational potential energy in terms of theta. So it's only me who knows that when it comes to substituting it in here, I must call that loss, I must call it a gain by introducing a negative sign, because I want everything to fit into my expression. This expression never fails. And I'd like to challenge any student out there. If there is a question which you have worked out and you have tried to use that expression and it fails, let me know what that question is, and then we can look at it together. And that is how you would work out question number 4. Let's go to question number 5. Okay, here we are at question number 5. Let's see what it talks about. A cyclist and her bicycle have a total mass of 84 kilograms. She works at a constant rate of p watts while moving on a straight road which is inclined to the horizontal at an angle theta. So this is the situation. Straight road inclined to the horizontal at an angle theta. So here we've got the cyclist. The mass is given. One of the forces acting on the cyclist is the weight of the cyclist, which is obviously 840 newtons down, vertically downwards. Of course, even without reading the rest of the question, I would think that there will be a component of that weight down the incline, which will be 840 sine theta. But let's check what we've been given in the question. Where sine theta is 0.1. So this one will be 840 sine theta, which is 0.1. And this one will be 84 newtons, like that. Of course, we know the cyclist exerts a certain driving force, Fd. And somewhere at the back of the mind, I know Fd is going to be equal to power divided by speed. Power divided by speed. When moving up the hill, the cyclist accelerates at this much at an instant when the speed, so when this is the case, the acceleration will be 1.25 meters per second squared. When the speed is what? When her speed is 3 meters per second. What does this help me to calculate? I can be able to calculate the acceleration at that point, because I'm going to say resultant force on the cyclist is equals to ma. Resultant force will be Fd minus Fr, which is 84, or the component of the weight down the incline. I think before I write down that expression, let me try to find out whether there is anything else which is asked for. When moving downhill, the cyclist's acceleration is the same at an instant when her speed is 3 meters per second. The resistance to the cyclist's motion, whether the cyclist is moving up or down the hill, is R. Find the value of P and R. Okay. Let me see. I think there is a problem here. According to the question, I have typed this question wrongly. When moving downhill, the cyclist's acceleration is the same at an instant when her speed is 10. This is supposed to be 10. So there is a correction there. 10 meters per second. So the resistance to the cyclist's motion, so definitely this is the resistance R, like that. So there are two forces which are opposing her motion, that is R and 84. So FD minus the forces which are opposing her motion is going to be equal to 84 times A, which is 1.25. This one will be the driving force. The driving force is power divided by the speed she has at that point. Power divided by the speed, which is 3 when moving up the hill. So minus 84 minus R is equals to 84 times 1.25 should be 105. And of course this one will be equation 1. There are two unknowns, P and R. So I've got to get the other expression when she's moving down the incline. When she's moving down the incline, this will still be her driving force. The component due to her weight will be 84. Our resistance to the motion R acts in the opposite direction. She's now accelerating down the incline. And again, I use the equation F is equal to MA. In other words, resultant force on M is equal to MA. What is the resultant force? This time it must be 84 plus FD, but FD is again her power divided by her speed down the slope, and that is 10. These are the two forces which are moving in the direction in which the acceleration is acting. So those two forces minus the force which is opposing that motion, which is R, is going to be equal to 84 times 1.25, because the acceleration is still the same, 105. So we have here, we're going to have 84 plus P over 10 minus R is equals to 105. And this is equation number 2. Now, because here I've got minus R and I've got minus R, I can have equation 1 subtract equation 2. Okay, it does not matter whether it is equation 1 subtract equation 2 or the other way around, 2 minus 1. It will still work out. So let's look at this. This is P over 3 minus P over 10. So here I have P over 3 minus P over 10. For that one, here I have minus 84 minus 84. And here I'm going to have minus, I think, 168. I have minus R minus minus R, and the R's are going to work to cancel out, because that was the main aim, to get R to cancel out. And I have 105 minus 105, I get 0. So over here I have P over 3 minus P over 10 is equals to 168. And here I think I need to use the LCM. I think I have 30. I think I have 10p minus 3p is equals to 168. And this one will be 7p is equals to 168 times 30. 168 times 30. And that will be 5040. And the power will be that number divided by 7, and I have 720 watts. Once I have the power, I can come and substitute into an equation like number 2 here, where I'm going to have 84 plus the power, which is 720 divided by 10 minus R is equals to 105. This, of course, is 84 plus 72. That will give me 156. So if R crosses the equal sign, I'm going to have 156 minus 105, and I'm going to get 51. Resistance to motion is 51 newtons. So again, checking the marking scheme. I haven't checked the marking scheme yet to see what it is giving and the answers. And I usually like to work out those questions this way, because I usually want to put myself in your shoes, where you're working the question without knowing what the answer is, so that I can put myself through the same struggle as you are doing when it comes to understanding the question, when it comes to seeing, to think in real time. I think about how to solve the question, because that is what you will go through. So by us going through this question together, so that you see that you're not alone, and you try to copy or imitate maybe what I do. If what I do is something which is which can be able to help you to work out the question, then well and good, because that is the main idea. So I may not know what the answer is, but you can easily check the answer, or you can easily see a mistake which I've done here. Just to put it in the comments below, because like I've always said, my aim is for you to be able to see the method that I'm using. Once you see the method that I'm using and you try to adapt that method, then it can be able to you can be able to get assistance from that. So that is how we would work out question number 5. Let's go to question number 6. So let us look at question number 6. In this question, we are told that two particles, A and B, start to move at the same instant from a point O. The particles move in the same direction along the same straight line. The acceleration of A at time t seconds after starting to move is A meters per second squared, where A is a function of time. We are required to find A's velocity when t is 200 and when t is 500. So this is the point from which they start moving, point O. So there are two particles. There is particle A and there is particle B. So this is particle A. And when we look at particle A, we are told that its acceleration is a function of time. That means that the velocity can be obtained by integrating that function with respect to time. So let's do exactly that. So we integrate this function here, 0.05 minus 0.0002 t dt. When we do that, this one of course becomes 0.05 t minus 0.000. If I divide 0.0002 by 2, because I've got to get 2 there, I will get this 0.0001 t squared. Of course, plus a constant, which is c. Now, what is the value of this constant? We can get the value of this constant by looking at this, that the two particles, they start to move. So the initial velocity of A is 0. That means that since now velocity is a function of time, it means that the velocity when time is 0 is 0. So if I substitute 0 in these expressions, I'll get that the value of c is 0. So v when t is 0 is 0. That implies that the value of c is 0. So we won't write it in that expression. So let's get the value of the velocity when t is 200 seconds. Of course, here, don't forget we're working out part 1. So we are just going to substitute this value over here. So we are going to have 0.05, of course, times 200 minus 0.001 200 squared and that will give me give me 10 minus and this will give me 4 and that will give me 6 meters per second. That is the value of the velocity of A when t is 200. How about when it is 500? So v when t is 500, we repeat the same expression. Find that this one will be 0.05 times 500 minus 0.0001 and this is 500 squared, and this will give me this will give me 25 minus and this again gives me 25, and we find that the velocity when t is 500 is 0, so it has come to rest. So that is how we would work out the velocities of A when t is 200 and when it is 500. Let's look at part 2, We are told that B moves with the constant acceleration for the first 200 seconds and has the same velocity as A when t is equals to 200. So this is B. After a time equal to 200 seconds, its velocity will be the same as 6 meters per second, and after a time of B moves with a constant acceleration for the first 200 seconds and has the same velocity as A when t is 200. B moves with a constant retardation from 200 to 500 seconds, that is for the next 300 seconds, and has the same velocity as A when t is 500. So after a time of 500 seconds, it is moving with a different velocity. So we can say after an interval of 300 seconds, its velocity is 0. Velocity is 0. So because that is the information that we are provided in the question. Yeah. So you need to read this part carefully. Find the distance traveled by A and B. Find the distance between A and B, that is the particles A and B, when t is 500. So the separation between them. So all I need to do is to get the displacement of A, and then maybe I find the difference between the displacement of A and the displacement of B. That will give me the distance between them. And let me start by working out the displacement of particle A when from t is equals to 0 all the way to t is equals to 500. That means I'll have to integrate this function further, but then the limits of integration will be given, which means I won't need the constant of integration in that case, because the limits of integration will be given. And then I substitute 0 and 500. And let's start with that. So let me go to this part. So I'm talking about part 2. So I'm talking about the displacement of particle A. So it's going to be equal to the integration of this function 0. I think it was 0.5 t minus 0.0001 t squared dt from 0 to 500. So this one will be 0.05 t squared divided by 2 minus 0.0001 t cubed divided by 3. Then I substitute in this limit 0, 500. So let me start by doing the first part. 0.05 times that will be 500 squared. All that I'm going to divide by 2 and I get 6250 minus the next one will be 0.0001 times 500 cubed, all that divided by 3. I'm going to get 4166.666 recurring. So we can say here I have 41.6, just rounding it up to that value. So I'm going to have 6250. I subtract 41, 67, and I get 2083. 2083 meters. So that is the displacement of particle A. So I need to get the displacement of particle B. Now, how is particle B traveling? Let's go back to the previous slide. Over here, we have been told that for the first 200 seconds, it's moving with the constant acceleration. It's starting with u of B being equal to 0, and its V at this point is 6 meters per second after this much time. Can I be able to calculate the acceleration it has here? I have V, U, and T. I can work out the acceleration using A is equals to, using the equation V is equals to U plus AT. And let's do exactly that. So for particle B, I'm going to work it out here. For 200 seconds, its acceleration, which I'm going to call it acceleration 1, is going to be equal to V minus U over T. This one will be 6 minus 0 over 200, and this will be 3 over 100, which will be 0.03 meters per second squared. That means that I can work out the displacement it has there, which will be ut plus a half at squared. U was 0, so it makes ut to be equal to 0 plus a half. The acceleration, I've just worked it out to be 0.03 times 200 squared. Let me see what that one gives me. So I get 0.5 times 0.03 times 200 squared. Get 600. That is for the first part when it is moving with uniform acceleration. Then I'm told that then a B moves with the constant retardation, uniform retardation from 200 to 300 to 500 seconds. That is, for a period of 300 seconds, it is moving with constant retardation. We need to know what that retardation is. So let me just see whether I can be able to work it out here, so that can I be able to use the same equation A, which I'm going to call A2, is going to be equal to the final velocity at that point is 0 minus the initial velocity will be 6 divided by, again, 300 seconds. That will be 6 divided by 300, and I get 0.02 meters per second squared. Can I be able to work out S2? Maybe using ut plus a half at squared. Why not? I know u at that point is 6 and t is 300. And I can have a half here. The acceleration is 0.02 times 300 seconds. Okay, it's getting a bit crowded there, but I hope you can be able to see that. This first part gives me 1800. Now I forgot a negative sign here. There is a negative sign there. It's a negative sign there. So that will make this one to be negative. The 0.01 300 squared times 0.01, I get 900, and this will be 900 meters. So the S of B is going to be equal to the first displacement, which was 600, plus the second displacement, which is 900, and that will be 1,500. So you can see that it's obvious that the displacement of B is less than the displacement of A. So I want to get the difference between them. So SAB is going to be equal to the displacement of A, which is 2083, because I have to get the difference between them, minus 1,500. Let me see what that gives me. 2083 minus 1,500, and I get 583. So this equation combines integration. So I want to emphasize that you must understand the concepts of integration and differentiation, because they always go together, although we never differentiated, but you can see I was mainly using integration. Then it also combines a knowledge of the equations of uniformly accelerated motion. It's just about understanding the whole problem and then trying to apply what you know, what we have learned in kinematics as well as in integration and differentiation. And that is how question 6 is worked out. Let's go to question number 7. So here we are in the last question, and let's read it together as usual. Particles A and B of masses 0.3 and 0.7 kilograms respectively are attached to the ends of a light and extensible string. Particle A is held at rest on a rough horizontal table. So this table is horizontal with a string passing over a smooth pulley fixed at the edge of the table. The coefficient of friction between A and the table is 0.2. Particle B hangs vertically below the pulley at a height of 0.5 meters above the floor. The system is released from rest, so U is 0, and 0.25 seconds later the string breaks. A does not reach the pulley in the subsequent motion. Find the speed of B immediately before it hits the floor. There's plenty of information here. And like I've told you in the past, when there is plenty of information, you try to break it down into certain manageable chunks. For instance, when I'm given the masses of these particles, and these particles, one of them is resting on a table, the other one is hanging freely, I can start by indicating the weight, because I know the relationship between the weight of the particle and the mass. W is equals to mg. And that will give me the weight of this particle to be 3 newtons. The weight of this particle here to be 7 newtons. There is a string here, so I can again indicate the tension there. Tension pulls this object this way. This tension pulls B upwards like that. The next is what? I know that mu is given. This is the value of mu. So I know, because the surface is said to be rough, there is resistance force here. There is friction force. So I can indicate that friction force there, and I can say it is equals to mu r. Mu is 0.2. Do I know the value of r? Of course I do. this is r, and r is equals to 3, so I multiply it by 0.3, and you find that I get 0.6. Notice that I do not know where these values, where this information is leading me to. I'm just trying to break down the question, which is something that I would want you to be able to do, because as you try to break down the question, you get to understand what you've been asked to calculate. What else is given? This distance is given over there, and you're told that the system is released from rest. That means u is 0. So u is 0 for this particle. U is also 0 for this particle. So whatever speed this one gains is equals to the speed that this one gains. So again, so long as they are attached to the same string, which they are, until the string breaks after 0.25 seconds. We are required to find the speed of B immediately before it hits the floor. This final velocity here, what is its value? So this is how I would approach this question. I know that point B, when it is at this point, immediately it is released, u is 0, and then it moves with a certain value of acceleration vertically downwards. We can call that acceleration 1, because there will be 2 accelerations. There will be 2. Why 2 of them? There is the acceleration when the string breaks and now B falls freely under gravity, and there is the acceleration when B is connected to this string. So those are the 2 accelerations. Now, if I can work out the speed it has just before the string breaks, I can be able to calculate the amount of speed it will have when it just hits the floor, because I can't use one single equation for the whole motion. So let me therefore start by working out this acceleration 1, and it is possible to work out that, because I will say for particle A, I will say F, a resultant force on it is equals to ma. Resultant force on it is T minus friction, which is 0.6, is equals to 0.3 A, and we can be able to see that that is the first equation. That is the first equation. We can't go further than that. Let's look at particle B. Applying the same equation, I'm going to have 7 minus T is equals to 0.7 A. Again, this was the first equation. This is the second equation. I can now put them together. Let me put the second equation here. 7 minus T is equals to 0.7 A. And if I add these 2 equations downwards, in order to get rid of T, I'm going to get 1.0 A is going to be equal to 6.4, and the A that I'm calling A1 is on, which is now 6.4 meters per second squared. And now I can use this acceleration to get the speed that A has after 2.5 seconds. So let me see the velocity of A that it has after 2.5 seconds. I can use V is equals to U plus AT. U for it was 0. The A, I've just worked it out to be 6.4, and the T is 0.25. That gives me 1.6 meters per second. That means that when the string breaks, a B is having the same speed vertically downwards when the string breaks. Its acceleration was 6.4 meters per second. So what is it that I need? I need the final velocity of B just before it hits the ground, the speed of B immediately before it hits the ground. At that point, when it just makes contact with the floor, what is its speed? What do I need? Now, I've got the speed it has in the second motion. So again, for particle B, I can say the second acceleration is actually equal to g. We know how much that one is. Its initial velocity for this second motion is equal to the final velocity for the first motion, which is 1.6 meters per second. And I want the v. The v it has there. So what equation can I use here? Can I use v is equals to u plus at, in which case now I will need the t that it takes to travel from when the string gets cut to when it hits the ground. I don't know that t. Supposing I were to try and use the third equation, which is v squared is equals to u squared plus 2as. I will need the s that it covers at that particular point. How about the second equation? S is equals to ut plus half at squared. I will need the u, which I know. I will need the t, which I do not know. But there has to be a point. Let me try to use v is equals to u plus a t so that I can be able to calculate the u it has is 1.6 plus the a it has at that point is 10 times t. This is the T2. So you can see I can't move further than this. So supposing I want to work out the displacement it covers for this duration, 0.25 seconds. Supposing I want to work out that displacement, and I would use the equation, the third equation, and I get s is equals to v squared minus u squared over 2a. I have the v, which is 1.6 minus 0 squared over 2 times 6.4 2.56 divided by this one will be 12.8. This will give me 0.2 meters. So out of 0.5, I have covered 0.2. The final displacement S, maybe let us say, let's call this one S1. S2 will actually be 0.5 minus 0.2, which will give me 0.3 meters. So I have the final displacement that that particle covers. I have the initial velocity. I need the final velocity. And remember, I know the acceleration. Acceleration is acceleration 2, which is g. So I can use v squared is equals to u squared plus 2as. The u is now 1.6 squared plus 2 times 10 times 0.3, 2.56 minus 6. Actually, this is supposed to be plus. Because this one will be 8.56, and the final velocity of b just before it hit the ground will be the square root of 8.56. And this is 2.9257, recurring with many digits there. We can say it is 2.93. And that is how you would work out the speed of B just before it hits the ground. You can see that here I'm using F is equals to ma equations of uniformly accelerated motion. It's quite confusing. Again, just like question 6 is about understanding what the question is all about. And then once you understand what the question is all about, you're able now to apply what you know, what concepts you know. In fact, this is everything about mechanics. Mechanics is about understanding what the question is asking you to calculate. And then once that one is very clear in your mind, then you go back and see what is it do I know about this particular area? What concepts do I know? Can they be applied? It's about application of these equations. Because I know you may have found yourself in this situation. You find that you can remember all the equations that are supposed to be used, but you don't know how to use them. So when you work out so many questions in mechanics, you get to understand how these equations are used. You get to know when to use certain equations and when not to use them. So let's look at part 2, where you're asked to calculate the total distance traveled by A. Let's look at what happens to A. There's some distance that it covers when it has an acceleration of 6.4 meters per second squared. By the way, in the whole of this slide, I'm just working out part 1. So I'll go to the next slide whereby I'll work out part 2. When it has this acceleration, we can work out the displacement that it covers, because we actually do know the time it takes. It takes 0.25 seconds. So let us say when it has this acceleration, meters per second squared, and the time is 0.25 seconds, we can work out the displacement that it covers by using S is equal to, can say S1 is equals to U T plus a half AT squared, because it started from rest. So it will be 6.4 times 0.25 squared. This is actually 0.2 meters. Now when the string gets cut, maybe it gets cut at this point, after it covers 0.2 meters, it doesn't stop there, so it continues moving in that direction. So I want to calculate the acceleration that it has, which is acceleration 2, and we are going to say that when we apply the equation F is equals to ma on it, the force acting in the direction in which it is moving is 0. So I subtract the force which is opposing that, which should be the friction force, which is 0.6 newtons, 0.3 A2. So A2 is going to be equal to minus 0.6 divided by 0.3. This is 2 meters per second squared. Now I can use that acceleration to work out S2. In S2, I know that the speed it has here is 1.6. Now finally it will have to stop at some point here where V is 0. So for me to work out S2, let me see whether this equation will work out. I'm avoiding the equation with the time because I do not know the time. So this one will be 0 squared minus 1.6 squared over 2 times, of course, minus 2. This one will be 2.56 divided by 4. This will be minus. That gives me 0.64 meters. So the actual distance that is covered by A is equals to 0.2, that is S1 plus 0.64, which is S2, and this is what gives me 0.84 meters. And that is how you would work out the last question in this paper. If you have a problem with any of the questions, it's very easy. If you hover the cursor over the scroll bar, you will be able to identify, you will see questions pop up. I have put timestamps in this video so that you can be able to locate the questions that you've got most difficulties in. So until next time, so if it is your first time to this channel, consider subscribing because I'll be uploading a solution to full papers, mechanics papers. So if you have not subscribed, go right ahead and do exactly that. Otherwise, see you next time when I upload the next paper in Mechanics 1.